basically going to be a whole new game.
All right, let me share my screen. Okay. So we'll start here. So greetings, scholars. Let me see. No major announcements. We're going to be wrapping up chapter 1 today with section 1.6. We are at the top of week 7. So what that means is that our exam 2 is going to become available this upcoming Sunday. And then for 7 days, you can earn up to 100%. And then after that 7 days, there's a 10% late penalty. As always, as usual, if you have questions, feel free to unmute yourself to get my attention and we can talk about it, or you can type it in the chat. I am monitoring the chat as well. Those are the main points. Okay. So let me go like this. I go view. There it is. Okay. So for chapter 1 on graphs and functions, we're going to be looking at section 1.6, combining functions and composite functions. A few objectives. 1, define basic operations on functions. 2, form composite functions. 3, find the domain of a composite function. 4, decompose a function. And 5, apply composition to practical problems. So we have the sum, difference, product, and quotient of functions. Let f and g be 2 functions. The sum, f plus g, the difference, f minus g, the product, f times g, and the quotient, f divided by g, are functions whose domain consists of those values of x that are common to the domains of f and g, except for f divided by g, where all values x, where g of x equals 0 must be excluded. These functions are defined as follows. So 1, we have the sum f plus g of x is f of x plus g of x. The difference f minus g of x is just f of x minus g of x. The product f times g of x is f of x times g of x, and the quotient f divided by g of x means f of x divided by g of x, provided g of x is not equal to 0. Right? So what again? So what this means, right? This just means the function f. This just means the function f plus the function g. So f plus g, right? A common error that students tend to do, they see this x on the outside and then they try to distribute the x, right? This is not multiplication, right? So we're not distributing. That's not what's going on here. Again, this just means f plus g, right? This just means f minus g. This in this form just means f times g, and this means f divided by g. Okay. So again, I just wanted to kind of bring to your attention, again, we're not distributing. That's not what's going on here. Because if you do that, then it's just going to throw off your results, right? As you start working examples, if you try to distribute to x, you're introducing something that's not there, and you're not really reading the symbols properly, right? When you do that. So given this f and this g, find each of the following. Let me check Zoom one more time. Okay, got it. So I don't want to get too far ahead with so many people, without missing so many people. Okay. He'll be back. Maybe. Yeah, I'm not gonna get his back. Okay. Like this and like this. Okay. Cool. Okay. Yeah. So I let you guys in manually, one by one, and I take attendance as I let you all in. So if I don't say anything and you get into the Zoom, then that means you got your attendance credit, right? And I went on and checked it early, a little bit earlier than I usually do for my second week, because I was like, okay, we're missing a good amount of people, so let me just check it again. Okay, so this is the example where we left off. I know it's only been 5 minutes, but this is how far we made it. Where'd my image go? Okay, let's just go like this. Okay. All right, so this is where we left off. Okay. So given this f and this g, we're asked to find each of the following. So for A, we're asked to find f minus g of 4. Okay. So basically what we're doing there, we're going to find f of 4, we're going to find g of 4, and then subtract those two results. So then f of 4 is going to be what? 4 squared, which is 16, minus 24, which is a negative 8, plus 8 ends up being 0. So f of 4 ends up being 0. G of 4 ends up being 2. 0 minus 2, the result ends up being negative 2. I'm just not writing it out. You should write it out, but I'm just kind of being lazy, to be honest. And we have it. I'm going to show some other ways for at least these first couple of parts to kind of evaluate these. Okay, let's work on B. So this B just means f of 3 divided by g of 3. Now you can do it off to the side, like, write out f of 3, you get your result, write out g of 3, you get your result, and then divide those results. So if we plug a 3 into f, that's going to be 9 minus 18, which is negative 9, plus 8 is negative 1. 3 into g gives us 1. Negative 1 divided by 1 is negative 1. Okay. Again, I will write it out. I'm just not doing it for right now because I feel like it's not too bad, right? F plus g of x. Okay, so again, this just means, what does this mean? This just means f of x plus g of x. So just basically combine like terms. So if we say f plus g, we don't need to do any distributing, so we're just going to combine like terms. So x squared is one of a kind, so that persists. Negative 6x plus 1x is going to be a negative 5x. 8 plus negative 2 is going to be 6. So I just said f plus g, and I just combine like terms. If we do f minus g, we need to be aware to distribute the negative into g, right? So then f minus g, I think the x squared there are no like terms for that one, so that term persists. Negative 6x minus 1x is going to be a negative 7x. 8 minus a negative 2 is going to be 8 plus 2, which is 10. So plus 10. And then f times g, I'm not going to write that one out. But essentially, we're like foiling. So we need to say the x term times each of these terms here. We also need to say this negative 2 term times each of these terms here. We'll get a total of what? 6 results, and then we combine like terms. And I'm just going to piggyback off of my prepared notes for that one. And then for f, we're saying f of x divided by g of x. So since, let's see, it looks like we can factor f, right? So can we factor f into, are you losing battery life? Can we factor f into some form like this, where we have what, x and x? Right, okay, so because this second symbol is a positive, I know my two signs are the same. They're either both positive or both negative. Because this first symbol is negative, that tells me the larger number is negative, right? So we know they're the same and the larger is negative. So if they're the same and the larger is negative, then both signs should be negative. And then we're looking for two numbers that multiply to give us 8 and add to give us negative 6. And I think that's fairly straightforward. It's -4 and -2. Okay. So we were able to factor f of x into this form. So then if we said f of x divided by g of x, those x minus 2's are going to cancel. And we're just going to be left with the x minus 4. And because we had the x minus 2 in the original, we can't divide by 0. So then we have to throw out x equal to 2. Okay. Now, I was really just being lazy. I didn't write these all the way out. I just kind of put the results and kind of talked through it. But we have a prepared version right here. All right. Oh, and then one other thing before we get into that. So with A and B, I just want to showcase those in the calculator. Okay. So if I go to my y equals, this is a TI-83 plus. My x, my f is going to be x squared minus 6x plus 8. Okay. And my g, okay, let me just put it here. My g is x minus 2. Okay. So for A and B, because we're evaluating, we can do this in the calculator, right? So again, this is a TI-83 plus. I'm gonna go back to the home page. Okay. So now I want to call on those functions. I'm going to call on f. So on the right-hand side of the calculator, there's a button that says clear. Left of that button is a button that says VARS. I think it's short for variables. So I'm going to click on that. I'm going to go to the right to go to y variables. Number 1 for function, and I want to call on f. So I'm going to click on number 1 because we put f in y1. So for A, we want to find f of 4. Okay, and then we're going to say minus g of 4. So I'm going to go back to the variables, y variables, function, and then now I want to call on y2 because that's where we put g. So we're saying f of 4 minus g of 4. We should get a result of -2. Okay, and then for B, we're saying f of 3 divided by g of 3. So I'm going to click on variables, y variables, number 1 again. And for B, we're saying f of what, 3 divided by g of 3. Okay. We got a result of -1. You see it there. Those are the two that we can do in the calculator in this example. Okay. So then, let's see if I can get this to work. So we see our -2 here. We see our -1 here. Okay. I think we got these two results as well. So again, for E, they did x squared times x. They also did -2 times x squared. That's where this comes from. Then basically -6 times those two are here, and then 8 times those two. Then you combine like terms, and you'll get here. And when we did f divided by g, again, the numerator factors, they were able to cancel the x minus 2's. And again, we say that x cannot be 2, even though the final result is linear, right? And generally speaking, this domain is all reals. But because in the original, we had an x minus 2 in the denominator, 2 would make the denominator 0, so we have to throw that out. If we were to look at this graph, there's a hole or a gap when x is equal to 2. Okay, let me check on Zoom. Chat. Yeah, so I don't know about the bookstores like the land like that. Uh, I would say try to do the temporary trial again like you did before, where you got the extension. Otherwise, just keep trying to get access. Once you get access to Pearson, I might, we'll figure something out.
Is there an access code or something that we can do? Because I haven't been able to do any work for the past 2 weeks.
Yeah, that's
I don't know
so.
the contact, and they say I went to the what's his face, and it said I need to pay $103, and I'm very confused.
Yeah, you do have to purchase access to it. You do have
I
to purchase.
so I have to pay $103.
Yeah, you have to purchase access to Pearson. Yeah, yeah, you have to purchase that. You have to buy it. So that's why it was a temporary code, right? Because that runs out, and then they finally worked out the discount, and then that's how that goes.
Okay.
Yeah. Okay. Yeah, that's part of your like materials. Like, yeah, I don't know why they stopped it. Like, once upon a time, access to Pearson was included in your tuition. Like all of your books were included. I was like, why did they stop that? That seemed like that was a good move, right? It was a part of your tuition. So when you paid your tuition, you had everything. Like it already came with everything that you needed. But now it's like you're paying your tuition and then you still got to turn around and buy materials. Yeah, it's a pain. But I don't know why they do it that way, but that's how they decided to do it. Yeah. Why does it keep going away? Okay. Let's see if I do this. Come on. Come on. Right. Okay, that's there. Go like this. Okay. I think when I switch it back, it'll behave properly. Okay, that's fine. Okay. All right. Okay. Yeah, so we got to the bottom of this. Because remember the temporary access was like while they were trying to finalize the discount, then they got the discount active. And so the $100 is the discounted rate. But it should give you full access to My Math Lab for 2 years. Right. So any professor, if you use math, if you take any course that uses My Math Lab, that's actually a really good deal. I've had students like in the past, usually it costs like $120. And then you could only in the past it was like $120 and you could only use it again if it was the exact same book. But the way it's set up now, it's supposed to be $100 and you're supposed to have full access to My Math Lab for 2 years. Right. So that should be, I'm under the impression that that's like no matter what, it just said full access to My Math Lab, right? So you can hold them to that. So you're paying less and you're actually getting more than what it was in the past. Yeah. Okay. So then composition of functions. So if f and g are two functions, the composition of the function f with the function g, written as f composed g and is defined by the equation f composed g of x, just means f of g of x, where the domain of f composed g consists of those values of x and the domain of g, for which g of x is the domain of f, right? So this symbol, this is called the composite symbol, right? It's read f composed g, right? And what it means is basically the second function inside the first function, right? So f of g of x, right? Second function inside the first function. We'll talk about the domain in a couple of examples, right? So that's coming up. Let me just check Zoom one more time. Because I know I had some people coming late. Okay. I think we're okay. think we got the bulk of the wave. Okay. Every time I keep forgetting that every time I go away, I lose my little thing that I use. Okay. There is another way to do it. Okay, that's fine. Okay, and so this is a pictorial representation of like the domain. So if you consider your original domain, we take a set of input values, pass them through the function g. We generate a set of output values, g of x. And then we take those results and pass it through the function f, and then we'll generate f of g of x, right? So the domain of f of g of x comes from the domain of g, but there's a little bit more to that story, okay? So again, we'll see that when we start working an example or two. So in this one, given these two functions, we're asked to find each of the following, f of g of 1. Okay, so then again, with this symbol, a common error that students tend to do, they see this and they're like, oh, that's multiplication. Then they'll multiply, right? Or they might, like in this instance, they might try to distribute a -1. This is not distributing. We're not multiplying by -1, nor is this multiplication, right? What this means the second function inside the first function, right? So this means f of g of 1, second function inside the first function. Okay. So then g of 1 is going to be what? 1 plus 1? That's going to be f of 2. Okay. So then that's going to be 2 to the power of 3, which is 8. All right, so then g of f of 1. So that, what does this mean? This means g of, again, the second function inside the first function. So g of f of 1. All right, so this means g of f of 1 is going to be 1 to the power of 3. So then that's going to be g of 1. Okay. So all we did, we evaluated f of 1, we got a result of 1. Now we're taking that result, passing it through the function g, right? So then that's going to be a 1 plus 1, which is ultimately 2. Okay. So then f of -1, again, the second function inside the first function. So this means f of -1. Now f of -1 is going to be -1 to the power of 3, which is ultimately just going to be -1. So then that's going to be -1 to the power of 3. Which just happens to be -1. Okay. All right. So we got 8, 2, and -1. Yeah, I didn't need these pages. So there's our 8, our 2, and our -1. Let me put a pin in these. Right now I'm gonna leave these as an exercise. Again, you have to prepare notes on the next slide. and this is in my pre-recorded lecture. I'm going to put a pin in this one. If we have time, we'll come back to it at the end, which we probably won't. Where is it? Let's look at this one. Let's work on this one. So given this f and this g, we're asked to find f compose g and in its domain, and then for b, we're asked to find g compose f in its domain. Okay. So then working on part A, again, f compose g of x. This means the second function inside the first function. So f of g of x. Okay. So this means f of 1 over x. But then f is x plus 1. So this is going to be 1 over x plus 1. Okay. So that's our simplified function. So now let's talk about this 3-step process to find the domain of a composite function. So we have the domain of a composite function. Let's so the 3-step process that I like to do is first I find the domain of the inside function. And then I like to find the domain of the simplified function. And then thirdly, I like to take their intersection. Okay. So then in our part A, our inside function is g. So our first step, we're going to find the domain of g. So if we look at g of x is the reciprocal function. So for rational functions, the domain in general is going to be all reals except any x that makes the denominator 0. So that domain is going to be everything except 0. Okay. So then for the simplified function, the simplified function is where we got the 1 over x plus 1. So again, that's a rational, well, essentially a rational function. In general, for something like this, the domain is all reals except any x that makes the denominator 0, right? So I think that ends up being the same thing. And then the third step is take the intersection. Right. So then a set intersect itself is itself, right? So everything except 0, intersection, everything except 0 equals everything except 0, right? If we were looking at that graph, say this was our 0, we'd want everything to the left of 0. We'd also want everything to the right of 0, but because we do not want to include 0 itself, 0 would get parentheses. And then we would translate this graph into interval notation. So the far left is negative infinity up to 0. And then we go from 0 to infinity. Okay. Infinity in this context always gets parentheses. The zeros, because we do not want to include the zeros, they get parentheses. And we combine these two sets with the union. So here's our our domain is that basically we're saying is everything except 0. That was part A. Okay. Let me get a copy and let's work on part B. Oh, and there was something in the previous example I wanted to showcase. Yeah, I meant to show something here. Let me do this real quick. So in this previous example, just showcasing it in the calculator in a TI 83 plus, if I can get this to work. There it is. Okay. So then again, I just went back because I forgot to showcase this. So our f is x to the power of 3 or x cubed. Our g is x plus 1. Okay. So then I'm going to call on my variables, right? So the first one is f of g of 1. So if I go to variables, my variables, I call on the first function, f of g. So I need to call on the second function, variables, y variables, functions, and then number 2 for g. And that's when x is 1. We should get a result of 8. Then for part B, we did g of f of 1. So let's call on the function g. Open parentheses, let's call on the function f. We want to evaluate this when x is 1. The result should be 2. Okay. And then the third one is f of 1. So if we go back to variables, call on the function, call on number 1. That's where we have f. So we want to say y1 of the same thing. So f of negative 1, and the result should be negative 1. Okay. Let's see the time. Okay, we're good. I keep forgetting about that. You see this? There we go. Cool. This don't have to do the other stuff. It's just switch between those views. Okay. And then we were working on the next one. I just wanted to showcase that in the calculator. Okay. So we did part A. Yeah, let's work on part B. So for part B, I need a copy. That's decent. Copy and delete. Okay. Space. Out of paste. Oh, that's cropped.
Right where you left it, everything stays.
Okay. Come on. All right. So then for part B, let's g of f of x. Okay. So for B, we have g of f of x again. What does this mean? This means the second function inside the first. So this means g of f of x. Second function inside the first function. All right. So then this is going to be g of, now our f of x is x plus 1. Okay. So all we're going to do is write g like normal, but replace each x with the fuchsia thing. So then that's going to give us 1 over x plus 1. Okay. So that's our simplified. And then for the domain, first we want to find the domain of our inside function. In this case, our inside function is f, so the domain of f. So f is a linear function, so its domain is all reals. Next, we want to find the domain of our simplified function. So that's the 1 over x plus 1. That's a rational function. So for rational functions, in general, the domain is all reals except any x that makes the denominator 0. -1 makes the denominator 0. So that domain is going to be everything except -1. Okay. So then third, we want to take their intersection. Okay. So the first domain we have is all reals, right? Intersection, everything except -1, right? So what do these two sets have in common? Everything except -1. Okay. And so if we were looking at that graphically, say our positive x is in this direction, say here's our -1, right? If we want everything except -1, that means we're talking about everything to the left of -1, everything to the right of -1. But because we do not want to include -1, we use parentheses. So in interval notation, the far left is going to be what? -infinity up to -1. And then we want from -1 to infinity. Infinity in this context always gets parentheses. Because we don't want to include the -1, we use parentheses, and we combine these two sets with a union. This is our domain of our composite. Okay. Let me see, view. Like this. View. Okay. Come on. Thank you. Okay, so we got our simplified. So then, oh man, okay, I think it's just space. Okay, so there's part A. We got our 1 over x plus 1 and everything except 0. And then part B, 1 over x plus 1 and then everything except -1. Okay, and I think that's about, oh no, let's talk about this. I'm glad I skipped another one. So here, okay, so far we've been, working where we have given two functions. We take the composition of the two functions and we finish with the result. So now we're going to start with the result and work backwards, right? So we're asked to write this H as F composed G, and I'll let you know right now there's more than one correct answer here, right? For instance, one potential combination could be, let's start with the inside function. So if we let G, we could let G of x be 2x squared plus 1. If G of x is 2x squared plus 1, then our F of x would be what? 1 over the square root of x. So that way, when we do F composed G, we'll finish with this H. Let's do it another one. Okay, so then another possibility for G could be square root of 2x squared plus 1, like this. So if that's the case, then our F of x would have to be 1 over x, right? There are more, right? There's more that you can do. It's just you got to kind of think about it, and then just check if you did okay. If I said the second function inside the first function, does it work, right? So if we do F of G of x, will we get our desired result? I think that's about as far as we made it for my students earlier. There's a little bit more, and here's a type version of what we just experienced. I'm going to leave all this as an exercise for you all. Are there any burning questions before we close out? Any burning questions? I think that's the right location. Okay. So when this bar finishes loading, you'll receive a copy of anything that you saw me writing. And if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. We will meet back on Wednesday, same time, same place. Okay, guys, take care. Peace.